TXRX Systems Tower Top Amplifiers, or TTAs, are used in land mobile radio to enhance the receive characteristics of base station and repeater sites, and to give portables, mobiles, and handhelds better range and capabilities. TTAs can be as simple as an amplifier in a box on the tower, or may be more advanced, allowing interface with site monitoring equipment and software, tower and feedline monitoring, or even signal monitoring. TXRX Systems has a long history of tower top amplifiers and other RF site equipment and offers some of the most advanced and reliable components available. This training module will cover basics of receive site tower top systems, their uses, technology, and application. More detailed information will be included in the next sections. As with all of our training material, we will provide a table of contents to assist you in finding what you need. This section is an introduction to tower top amplifier systems and will include the topics listed. In a receiver system, loss ahead of the first stage amplifier of the system is directly additive to the noise figure of the amplifying device itself. Losses from passive devices such as feedline after this primary stage and noise added by other cascaded active devices after the first stage, though minimal, do contribute to an increase in the overall system noise figure. As the signal goes through the transmission line, the signal amplitude is attenuated proportionally. LDF or AVA550A feedline has 1 dB of loss per 100 feet at 800 MHz. Therefore, the incoming signal amplitude will be attenuated by 3 dB when it is passed through a 300-foot feed line, with an impact on receiver sensitivity. There are situations in which a TTA should not be used. As a general recommendation, a TTA should be included only for those systems having 1.5 dB or more in transmission line loss between the antenna and the system receivers. This means that the TTAs are not recommended for short towers or any system with a short receive transmission line. Care should be taken on rooftops and water towers or other short structures. Signals are attenuated due to free space path loss, terrain, and other obstructions. Signals and external noise are attenuated as they travel through the feedline, connectors, filters, and other components of the system, but thermal noise is not. Free space path loss is a result of the unobstructed distance between antennas in a system. One of the basic laws of physics is that electromagnetic energy varies by the inverse square of the distance away from a radiating body. What that means for LMR engineers is that every time the distance doubles, the signal levels drop by 6 dB. A 6 dB decrease in power means that 3/4 of the power is lost and 1/4 remains. Terrain and other obstructions, and even the curvature of the Earth, will further reduce the levels of the signal arriving at the receive antenna. These are basic facts for all radio communications and can be improved upon in a system by increasing the power output of the transmitter, using antennas with more gain, and/or increasing the height of the transmitter-receive antenna. A TTA cannot reduce overall path loss. It does, however, preserve the signal-to-noise ratio of the signal arriving at the receive antenna. In most radio communication systems, the base or infrastructure transmitters have a much higher transmit power than the mobile or portable units, also called the subscribers. For many of the subscribers, their radios may have significantly less transmit power, limiting their ability to achieve a high signal-to-noise ratio at the infrastructure receiver. This creates an unbalanced system that is talk-in limited. Based on the power levels and location of the receive sites, a TTA may improve the talk-in ability of the subscribers in a system. The receive system and the TTAs will have to be optimized, balancing the gain needed for distant communications against the possibility of receiver overload. Receive systems are noise and distance limited. Radio frequency noise is all around us, generated in our environment, produced in our atmosphere by the sun. Many of our human activities, such as cell phones, computers, cars, trucks, and any electrical equipment, produce RF noise. The noise is continually generated. Signals are attenuated due to free space path loss and are further attenuated as they travel through feedline, connectors, filters, and other components of the system. For any signal received by the system, the best signal-to-noise is at the output of the receive antenna. The purpose of the TTA is to preserve that signal-to-noise ratio to the extent possible. Amplifiers also produce noise as they amplify both signals and external noise. The additional noise is superimposed on the signal as it passes through, degrading the signal-to-noise ratio. The amplifier increases the level of the input signal by its gain factor as shown on the diagram. And if the amplifier was perfect, the input noise would be amplified only by the gain of the amplifier. But amplifier noise is added as shown by the green line. This is called noise factor and is a measure of how much noise is added to the signal by the amplifier. To calculate the noise factor, the signal-to-noise ratio at the input is divided by the signal-to-noise ratio at the output. The noise figure is the noise factor expressed in dB. Amplifier specifications will provide the noise performance as noise figure. The TTA helps to protect sensitivity by boosting the signal level before it encounters the passive losses and additional noise of the system. TTA systems and uses are explained first in this section. We will cover what they are, why they are used in land mobile radio, and when they should not be used. The simple explanation of a tower top amplifier is that it is an amplifier in a waterproof box at the top of a radio site tower used to amplify received signals within the designated passband. The TTA should include a filter or preselector to keep unwanted signals out of the receive system. The TTA is mounted as near as possible to the receive antenna, keeping jumpers as short as possible. Any electronics mounted on the tower must be waterproof and wind and lightning protected. While we refer to the equipment as a TTA, the system includes a control unit mounted in the equipment shelter at the base of the tower. Why are TTAs used in LMR systems and what is their application? The received signal for police, fire, EMS, and other services is most pure at the output of the antenna and degrades as it travels through the components on the tower. Anything between the antenna output connector and the receiver input degrades the signal. TTAs are used in receive systems to protect sensitivity, maintain signal-to-noise ratio, improve coverage, and to eliminate losses caused by transmission line. There are situations that do not require the use of a TTA, and some conditions where they should not be used. LMR receivers will be driven into descents if too strong of a signal is coming into their front end. A TTA is not necessary if the loss between the antenna and the receiver is less than 1.5 dB. This diagram shows that land mobile radio systems are now called upon for a great deal more than they ever have been in the past. LMR radios have expanded to include data and monitoring, video, and what is now known as a body area network with body-mounted cameras and telemetry. TTA systems are and will increasingly become more dependent on the Internet for system notification and control interfaces with system stakeholders. But still, the primary use of first responder radio in emergency conditions is voice communication, and the TTA is a vital part of that system. The TTA is mounted as near to the receive antenna as is possible and practical. Coverage, while not discussed here in detail, is based on multiple factors, including height above average terrain, how high up the tower the receive antenna is mounted. The higher the antenna, the larger the coverage area, but the longer the feed line and higher the line loss. The primary job of the TTA is to overcome the feedline loss in the system, effectively moving the receiver up the tower to the receive antenna. In the diagram, the control unit would be rack-mounted in the equipment shelter near the system receivers. The diagram shows that the control unit is required to interface with multiple off-site platforms such as desktop computers, monitoring systems, servers, and even cell phones, in addition to the receive system. The main use of the TTA is to overcome the feedline loss and other losses in the system and to preserve system sensitivity. Land mobile radio is a constant battle on the receive side. Close to receive sites, reception will be fine, but as the portables, mobiles, and handhelds move away from the base or repeater site, reception weakens. Emergency response radio users need strong, consistent communications. Transmitters are basically big amplifiers. Receivers are not. Receive systems are noise limited, and the subscribers in the system are power limited compared to the system transmitters. Several very basic conditions limit land mobile radio and all radio communications. Free space path loss is the loss caused by the distance between transmit and receive antennas. Almost everything produces RF noise of one type or another. The receiver itself produces noise as the signals enter and go through the receiver. Although it doesn't make sense that a loss produces noise, any reduction in signal while the system continues to produce noise is the same as an increase in noise and is known as the noise factor or noise figure. Keep in mind that on-channel noise cannot be filtered. Properly installed, properly optimized, and properly used, the TTA helps overcome the increase in noise and loss of sensitivity. TTAs from TXRX systems are more than an amplifier in a box on a tower. TXRX Systems has been manufacturing tower-top amplifiers since 1995, holding patents for the initial designs and concepts. The systems were large and heavy, manufactured in stainless steel boxes to be able to withstand extreme weather conditions and protect electronic components on the tower. But they were built to be fail-safe, with backup amplifiers that would be manually switched in to maintain public safety communications in the early 421 models. As TTA engineering progressed, automatic switching was implemented in the 422 versions. The units were also provided with a test port used to measure system performance. As TXRX developed and built more advanced models, and as components continued to shrink in size and integration, the tower-mounted boxes continued to get smaller, with amplifiers improved in their noise figure specification. Smaller boxes on the tower, as well as the use of stainless steel, brought several things, including lower wind loading and greater longevity. While still heavy to be hauled up the tower, the weight reduction helped installation and mounting requirements. The 426 models went into a smaller stainless box, and the 428 models brought higher integration, with all components being combined into one module in yet a smaller enclosure. During system design and equipment purchase stages, care must be taken to select the right equipment. In the United States, land mobile radio systems come in two versions that will make a difference: standard reception and diversity reception. Standard or non-diversity reception uses a single receive antenna, feedline, and a single input on receivers. Diversity reception doubles all equipment in the receive path. TXRX Systems has been designing and building tower-top amplifier systems for nearly 35 years, applying for and receiving patents for the equipment. TXRX has produced proprietary models for major land mobile radio manufacturers during that time, adding features to the systems as needed. TTAs in the 420 series or families of TTAs were all produced as standard or non-diversity systems for networks using traditional modulation. With the advent of P25 in 1988, the United States Congress started the process of mandating interoperability between radio networks and the use of digital encoding of information carried. In 2012, products for P25 Phase 2 started becoming available, which included 2 TDMA voice channels in the same bandwidth as previous systems. TXRX produced the first diversity TTAs for those systems and continues to lead the industry. After determining diversity or non-diversity, the next decision in the TTA system selection is which type of control unit is needed. This will be based on what type of receivers will be used. Radio manufacturers arrange their receivers in 2 different methods: systems which distribute the received signal to multiple receivers, and systems which need multiple feeds to individual receivers. TXRX provides control units for both types of systems. In the simplest TTA system, a control unit feeds one output connector to a system with one input connector. The control unit performs several functions. One of the most important is supplying operating power to the TTA. DC voltage and current are fed to the TTA through the antenna feed line. The TTA feeds RF signals through the antenna feed line to the control unit, which is then connected to the receiver cabinet. The receiver cabinet supplies coupling to the individual receivers. Diversity TTA systems will have 2 RF outputs feeding 2 cabinets. The control and distribution unit has multiple outputs feeding multiple receivers. The number of output ports is typically built for 8 or 16 connections, but can be expanded to 32. The control and distribution unit will have amplification on board to overcome the coupler losses and feeds operating voltage to the TTA through the antenna feed line. Each type of control unit can be used to feed LMR receivers, distributed antenna systems, or to send signals anywhere needed. Control units must match the model number of the TTA. Both control units and control and distribution units are available for standard or non-diversity and for diversity systems. Diversity systems are sometimes referred to as dual diversity and require doubling of all signal path elements on the control unit in order to feed 2 balanced signals out. Control units must be matched to the TTA model number, which requires that both must be in the same family of TTA systems. Models or part numbers must match. If a TTA is a 434B model, the control unit must also be a 434B and not a 429. Over the years of production, changes have been made in electronics, communication, features, and in design approaches, all of which led to differences in software and firmware, as well as hardware. TXRX Systems continues to lead in TTA development and production. Many different models of TTAs have been produced since their introduction in 1995, keeping LMR communications for first responders solid. TXRX has worked with all major LMR radio manufacturers to build life-critical application radio infrastructure equipment. When lives are on the line, second best won't do, and first responder equipment must work first time, every time. TXRX continues to produce state-of-the-art TTAs that incorporate survivability, connectivity, and security for public safety systems. New TTAs are being designed on a new platform that will allow for future enhancements and expandability. TXRX Systems continues to design platforms that will allow for future innovation, taking current TTA models forward with new advances in design and technology. The TTAs of the future will be more flexible within the family platforms to meet customer needs. Based on current chipsets and onboard computers, future enhancements will be implemented without full redesign. TXRX Systems 440 family of products are designed with a single circuit board in the TTA, making them streamlined in construction and assembly. Lightning arresters or surge protectors are being integrated into the design. Splitters, couplers, and filters continue to get smaller, making the TTA on the tower and the control deck in the rack smaller, lighter, and easier to install. The TXRX 440 family of TTA systems will continue to grow with added features and simplicity of installation. The TTAs are fed their operational power through the main system feedline from the control unit in the equipment shelter. Surge protection is integrated into the TTA housing rather than being external, providing protection for the TTA. The TTA is designed for installation under extreme adverse weather conditions and is water-sealed and vented. New features are being added with the TXRX design. The 440 family of TTAs will be web accessible for control and monitoring. The onboard processor will allow for future enhancement and programming. The system will have fail-safe and test bypass, meaning that if there are problems on the tower, the unit will bypass and will not stop communication. Thank you for being part of this training module, for inquiring about TXRX systems and services, and for being part of our technical community. This section was intended as an introduction to tower top amplifiers and how they are used in land mobile radio systems. More training modules are available in support of this and other topics specific to products manufactured by TXRX systems. The material is available in short versions and in longer half-day, full-day, and two-day classes. Visit our website at txrx.com for more information. Titles and topics are being added weekly, so please come back often to see what is available. Classes are available at TXRX Systems, 8625 Industrial Parkway, Angola, New York, or if your group or shop is large enough, we will bring the training to you. Please call 716-549-4700 to discuss fees and scheduling. Again, thank you for being part of this presentation, and we do invite you back.